Hello there and welcome to this week's edition of Engineering and You. It's a program where we talk about everything engineering and how it affects our daily life, how it makes our life better, and what engineering really means when it comes to our going out, our coming in, and our daily lives. My name is Tunde Olaniro, a regular anchor on this program, and then, like you know, it's a very interactive one. We don't only get to talk to you, but you get to talk to us as well and answer questions as we give to you every week. The program is sponsored by Prince Engineer Yemisi Shilon, and the question for today is: a girl of mass 50 kilograms stands on a scale inside a lift which descends at a constant velocity. What value of the reading indicated by the scale? The value of the reading indicated by the scale is what? You can have the options on your screen. A, less than 50 kilogram, B, equal to 50 kilogram, C, greater than 50 kilogram, and D, 0. If you know the answer, please pick up your phone and call us, or go to our social media platform as seen on your screen and drop in the answer. Just drop is A, B, C, or D. Then we'll get the prize across to you, courtesy of our sponsor, Prince Engineer Yemisi Shilon, FNSC. We'll take this short break. My guest is already in the house, and it's a big fish, let me use that word. But let's take this break. When we return, I'll let you know who he is and the topic he'll be treating with us today. Welcome back. My guest for today is Engineer Adetunji Ismail Adenuga. He is the incumbent chairman of the Nigerian Society of Engineers, Abeokuta branch. That's why I said I have a big fish in the house. Academically, he started from the secondary school, from Igomade Grammar School in Ota. From there to Ladoke Akintola University of Technology, where he studied civil engineering and obtained Bachelor's of Technology from there, master's degree in water resources and environmental engineering from the University of Lagos. He is currently director of flood and erosion control in the state civil service of Ogun State. Then he's also the Ogun State acting project coordinator of Nigerian erosion and watershed management. Engineer Adenuga, welcome to Engineering You today.
You are welcome, Mr. Olaniro.
And he will be talking about a very interesting topic, really. The topic is fundamental of calculus in engineering. I don't want to get on his way. He will actually take it off from here and explain to us what really is all this all about.
Thank you very much. And I want to say good evening to all our viewers at home. So the topic here this evening is fundamentals of calculus in engineering. As we all know, calculus is one of the very vital topics when it comes to engineering. That is why in school, while in secondary school, any student that is aspiring to be an engineer must take mathematics very serious, and such students must have a lot of interest in further mathematics. And one of these topics is calculus. And calculus has a lot of application in engineering. You can see, why do we study calculus? So if you look at it, engineering is a calculus heavy program. Like I've said, regardless of whether it is mechanical, electrical, or civil engineering focused. And calculus is one topic in mathematics that students of engineering in their first year. Wherever you are in the university, you have to take MTH. During the MTH, you do a lot of calculus, either in first semester, second. When you get to your second semester, the 200 level in the university, you also take some courses in engineering mathematics that involve a lot of calculus, and it has a lot of application. So if you look at the application of calculus, we have this application in electrical engineering. So look at it, if you have any electrical ever come from Maxwell equation. Maxwell equation is an example where we have application of calculus. You have differential equation. Wherever you are hearing differential equation, they are referring to calculus. Signal processing is also a calculus incline course, because we have Fourier series there and we have Laplace transformation. And without calculus, one can never understand the principle behind all these topics in engineering maths. Because Fourier series is an applied advanced engineering mathematics. So, and for electrical students, it is very, very important. They understand the principle behind the Fourier series and the Laplace transformation before they can get to know some of its application. So, and without knowing the basis of calculus, you can never dwell into that. When it comes to mechanical engineering, the rocket equation, rocket engineering, the rocket equation, the velocity is based on calculus, applied on conservation of momentum. So, likewise, when you are talking of beam, deflection of beam up and down, you want to balance something from a load, be it at a point load or a weight. We do that when we are doing momentum in our secondary school physics. You do, on this, you do some calculus as well when you get to an advanced level. Dynamics, or explaining how things will move in non-simplistic scenarios. So it's usually done in differential equation, which is also calculus. Then when it comes to chemical engineering, we are talking of fluid mechanics. We are talking of mass heat transfer and thermodynamics. And civil. And one of these, civil, we have a lot of application of calculus in civil as well, in structural engineering, the real-life structural engineering. If you want to calculate the heat loss in building, the forces in complex configuration of structural elements, and structural analysis in seismics, design requirements. All these are simple application of calculus in engineering. You can see it transfers across all the engineering field, almost all the engineering field. We've talked about civil, we've talked about electrical, we've talked about mechanical, we've talked about chemical. So now I want to solve some examples on calculus, so that, because most people find it difficult, calculus, this topic is very, very hard. How do I want to cope? So, but it's very simple once you understand the basics. So, like, look at the rule 1 now. If you have f of x, anything function of x, we term it as y. If you have our f of x to be a raised to power n, and we want to find the first derivative, that is the y dx, f prime of x, you have to multiply that n by the as, then the power, s now raised to that power minus 1, that's n minus 1. That is the simple analogy. If you now follow this, you can use this to analyze all the examples. Any example that relates. Look at that example where we are having 2s raised to power 4, 3s raised to power minus 3 plus 7s. Look at that 3. 4 for the 2s, 4 is the n. And to that 2 is the a we are having there. So you now multiply 4 by 2. Then the x raised to power 4 minus 1. So I have to introduce bracket in the second one because we are having minus. Because if you are having minus, that sign at the middle is going to change. That's also I have to put minus. I put the minus 3. That is the power of the index. So minus 3 multiplied by 3s raised to power minus 3 minus 1 plus the 7x, that x is raised to power of 1. You now have 1 into 7x raised to power 1 minus 1. Look at it, we now have 8x raised to power 3. Then minus times plus give us negative. You now have it as minus 9s raised to power s raised to power minus 4 plus 7s raised to power 0. And any number, be it 1 million, raised to power 0 is 1. Be it 10, be it any number raised to power 0 is 1. We now have the expression as 8s raised to power 3 minus 9s raised to power minus 4 plus 7. So you just leave our answer like that. And if you want to express further, we can express, for that we have to bring in indices. We now have that x raised to the power minus 4 will now become 1 over x raised to the power 4. We can now have our answer as 8x raised to the power 3 minus 9 over x raised to the power 4 plus 7. That's one example. Look at the second example. We're having 2x raised to the power 3 over 2 plus 3x raised to the power 4 over 3 plus 5x squared. So that x is our 3 raised to the power 2 is our n. That 2 is our a for the first part. We now have 3 over 2 multiplied by 2x raised to the power 3 over 2 minus 1. The second one, our n is 4 over 3. 4 over 3 multiplied by 3x raised to the power 4 over 3 minus 1. Then the last one, plus the n is 2. 2 times 5x raised to the power 2 minus 1. By the time we deduct that, 3 over 2 minus 1, the LCM is going to be 2. So 3 minus, that one is 1 over 1. If the LCM is 2, I mean we have 3 minus 2 over 2 for that. For the middle one, we have 4 minus 3 over 3 plus 10x. We now have it as 3x raised to the power half plus 4x raised to the power 1 over 3 plus 10x. That is the first rule. We can't be going through deriving the calculus from the first principle in this case. So that is why we just have, because we are on a television program. Look at this. If you have x to be an exponential function, that is, if our y is an exponential function, the derivative of an exponential function is the same thing. The y ds of y is equal to e raised to the power x is the same thing as e raised to the power x. So if you have sine x to be y, the y ds of sine x is cos x. If you have y to be cos x, the y ds of that is minus sine x. And if you have y to be tan x, the y ds of that is sec square x. So we are now moving forward. Under calculus, that is one rule. We have chain rule. So for chain rule, look at this example where we are having y to be what? 2 in bracket, we have 2x squared plus 1, everything raised to the power of 3. In this case, we can denote the equation within the bracket by an alphabet. So, but you normally make use of u, but you can use any alphabet. So if you put that to be u, that is our y will now be what? Our y, if our u is 2x squared plus 1. So the u dx will be what? That dot means times. In this case, if you use dot in mathematics, it means multiplication at times, like in this case. So we now have that as, that's 2, the power of 2 multiplied by 2x raised to the power 2 minus 1. And the differentiation of a constant, any constant is going to be 0. That's also why we are having that as 4x. Then from there, our y will now be what? Since our u has been 2x squared plus 1. So if you want to express our y, that means our y will now be, y will be equal to u raised to the power 3. And finding our dy du, following that first principle, that is n. Our n in that case is 3. Our a is 1 because we are having just u. So that is 3u raised to the power 3 minus 1. We now have that as 3u squared. And looking at that expression for chain rule, the y ds will be what? The y du multiplied by the u ds. So looking at that, we have our dy du multiplied by the u ds. We already know our du ds is 4x. And our dy du is 3u raised to the power 2, 3u squared. If you multiply that, we have it as 12u squared s. Now, let us now replace our u back. Recall that we take u as 2s squared plus 1. If you now put that back, we can now have it as 12s into bracket 2s squared plus 1, everything raised to the power 2. That's the answer. It's as simple as that. Then, look at another example under this chain rule. I'm using an exponential example. I have y to be e raised to the power 2x minus 1. In this case, that 2x minus 1, I can replace it with an alphabet. Now I said, let u be what? 2x minus 1. If our u is 2x minus 1, and we are differentiating the u dx, that s, 2x, s is raised to the power of 1. So if our s is raised to the power of 1, that means 1 multiplied by 2, raised to power 1 minus 1. 1 multiplied by 2, raised to power, 1 multiplied by 2s, that s raised to power 1 minus 1. And 1 minus 1 will be 0. S raised to power 0 is 1. That is why we are having 2. And the differentiation of 1 is 0. That was why we have our duds to be what? To be 2. Then our y will now be what? E raised to power u. If our y is e raised to power 2, the y du of exponential function is the same thing. You have it as e raised to power u. So now looking for our dy ds, we now have our dy ds from that expression. It will now be dy du multiplied by du ds, which is e raised to power u times 2, which is now 2 e raised to power u. And putting u back into the expression as 2x minus 1, we now have it as our dy ds as 2e raised to power 2x minus 1. Chain rule 2, this is another example I put for the chain rule. I'm having tan s raised to power 3 minus 2s. What I just need to do, that s raised to power 3 minus 2, I can replace it, denote it with what? With an alphabet, with u. So my du ds in this case will be 3 multiplied by x raised to power 3 minus 1. That was why we got 3x squared. Then that 2x is s is raised to power 1 multiplied by 2, x raised to power 1 minus 1. So s raised to power 1 minus 1, that means s raised to power 0. So we now have 2x raised to power 0, and s raised to power 0 will be 1. So that was why we're having that du ds as 3x squared minus 2. Then our y will be what? Our y will now be tan u, since we have denoted the equation in bracket with u. So the y du will be what? Will be sec square u for that. So our dy ds will now be sec square u multiplied by 3x squared minus 2. So we now have our answer as 3x squared minus 2 sec square u. But our u is what? S raised to power 3 minus 2s. If you now put it, you have our answer as 3x squared minus 2 sec square s cubed minus 2s. So another one is product rule. If you have product rule, that if you have y to be function of s, if you have y to be u of s multiplied by v of s, that is a product. Look at the expression. So the y du will be u dv ds plus v du dx. If you have, look at this example, you have s squared multiplied by 3s4 plus 2s squared plus. So we can take any one of them as u and any as v. But I took my u to be s squared and my v to be the equation in bracket. If you differentiate that, you have s squared, you have 2x. And if we differentiate 3s raised to power 4 plus 2s squared plus 1, we have 12s raised to power 3.
Okay. We have a call. Glory from away. Hello, Glory.
Good evening, sir.
Good evening. How are you?
My name is...
I hope you are enjoying our calculus class.
Yes, sir.
All right. Your question.
Sir, I want to ask that calculus, is it related to further math or only mathematics?
Is it related to further maths or only mathematics?
It's mathematics, further maths. You won't do calculus in under mathematics. You do it in further maths.
Okay, so sir,
you do it in further maths.
I want to answer the question.
All right, go ahead, Glory.
The answer to the question is B equals to 60.
Okay, I'll let you know if you are correct, Glory. Keep watching the class.
Okay,
Thank you very much.
So like I was saying, so if I now want to find my dy ds, I say my dy ds is u dv ds plus v du ds. So if I put my u to be s squared, which is s squared, my dv ds is 12s cubed plus 4s, plus my v is 3s raised to power 4 plus 2s squared plus 1, multiplied by my dv ds, which is 2s. If you open that bracket, you have that equation, but from that equation you have 12s raised to power 5 plus 4s cubed plus 6s raised to power 1 plus 4s plus 2s. I've collected the like terms. After collecting the like terms, we now have our answer as 18s raised to power 5 plus 8s raised to power 3 plus 2s. But if you look at that equation, 2 can cut all the quotient of all the numbers we are having there, and s can also go through. That is why we now put 2s outside. By the time you divide 18s squared by 18s raised to power 5 divided by 2x, you are left with 9x raised to power 4. If you divide 8x raised to power 3 divided by 2x, you have 4x squared, and 2x divided by 2x, you have 1. So that was the expression like that. If you open the bracket, you get that answer back. Then for the second example, I'm using sine 2s into 1 minus cos 2s. U is sine 2s, and V is 1 minus cos 2s. Look at that. If you, the u ds will be what? looking at that chain rule comes into play like this. That 2x, so you now have that 2 multiplied by what? This 2, I've make use of chain rule here. So that's 2. First of all, differentiate that 2s, and I have it to be 2. You now differentiate sine 2s as a whole. That will now give us cos 2x. Ditto to the v equals to 1 minus cos 2x. If you differentiate 1, you have 0. 1 is 0. Then if you differentiate cos 2s, you have, you first of all differentiate that 2s, that will give you 2. Is that right? That will give us what? That will give us 2. So if that gives us 2, so and cos 2s is going to give us what? Minus sine 2x. So that is going to be of minus sine 2x. So minus, there is a mistake in this slide. Let me just, I saw something. So, and the last one is the quotient rule. If you look at the quotient rule, you have, it's usually used for division. So you have u into s divided by v into s. And the numerator in this case is usually the u. You make the numerator as your u and the denominator as your what? As your v. Look at that example where we are having 2s squared plus s divided by s plus 1. Our u is 2s squared plus s. If you differentiate that, you have that to be 4x plus 1. Ditto to our v is what? Our v is s plus 1. If you differentiate that, you have 1. Now putting it, that is v du ds. Our v is s plus 1. The v ds is 4s plus 1. The u ds rather. Minus u. Our u is what? 2s squared plus s. And our du ds, our dv ds is 1. So if you simplify that expression, we have our final answer to be 2s squared plus 3s plus 2 over s plus 1 squared. And the last example here is how they arrive at, we are having tan under trigonometry. Under furthermore trigonometry, your tan or theta or tan x is the same thing as sine x over cos x. So this expression we are having as sine x over cos x is the same thing as tan x. So I just want us to know how they arrived at that set square s for the differentiation of what? Of tan x. So our u is going to be sine s and our v is going to be what? Cos s. If you, the u ds will be what? Cos s, and the v ds will be minus sine x. So if you have now v du ds, that is our v is cos s, the u ds is what? Cos s as well. Minus our u, which is sine s, and our dv ds is also minus sine x divided by v squared. V squared is cos s squared. So cos s multiplied by cos s, we have cos square x. Then that minus sine s times minus sine x, the one in bracket, you have it as sine square s. Everything cos s squared is cos square s. And in trigonometry, cos square s plus sine square s is also 1. So that expression cos square s plus sine square will now become 1 over cos square s. And 1 over cos under trig is sec. So that was why we are having 1 over cos square s to be sec square s. So that is the simple analysis of how they arrive at sec square s for the differentiation of tan x.
All right, thank you very much, Engineer Abeokuta, for this exposition. I'm sure you enjoyed it, but it's not magic. It's something that is practicable. It's something that is understandable. But we don't have much time any longer. We have to go. And for the question for the day, Glory from Away, you got it correctly. The answer is B, equal to 50 kg. So Glory, please, I'll give you this number to call, 003-086-7011. Call that number, you get your gift, courtesy of our sponsor, Prince Engineer Yemisi Shilon, FNSC. We have to go now. Our time is up. Thank you so much for watching. For the question for the week, as we go, a body in simple harmonic motion has an angular speed of 4 rand per second. What is the period of the motion, taking pi as 22/7? If you know the answer, the options are there. You can put it on our social media platform. And if you get it correctly, you get your gifts, courtesy of our sponsor, Prince Engineer MC Shilon, FNSC. Thank you so much for always being there. Thank you to my guest, Engineer Adenuga, for coming. We really, really appreciate your exposition on calculus. And like I said, it is not difficult. It is something you can understand. And we have to go. Thank you so much for watching. Tunde Lanino is my name. Until next week, where we have another guest, I say bye-bye.